Okay, it's gone.
It's county. Okay, so what we're gonna do today is we're gonna talk about vectors, okay? Kind of a little bit of a review of what you've done in physics as far as adding and subtracting and drawing vectors. Now, we have several different approaches to this that we're gonna look at in this class to begin with. Today, we're just gonna look at it from the standpoint of what you do when your vectors look like this. Now, you can draw them to scale. You can use an equation to make a calculation on a vector. However, since you're gonna have to submit this stuff, if you're gonna draw to scale, you're gonna have to have your own graph paper for everything and assign your scale. So we're not gonna spend a lot of time in drawing to scale, okay? We're gonna spend more time in making calculations, okay? So just bear that in mind. Now, I extended your homework for 2 days because you were out a week, you know, and I know I looked at the stats on there and y'all didn't do anything either till yesterday or this morning, so I'll give you 2 more days.
So is the homework which one are those, like sample problems 2.4 or?
It's problems, there are problems in there. In chapter 2, there are some problems, just like there are in the other chapters.
Ah,
And they've got numbers, not the sample problems that are worked out for you. That would be pointless, right? So, okay, so what is a vector? What is a vector? Just, what is a vector? A line that does what? Okay, points in a direction and represents what? In our case, probably a force, okay? What is a vector by description? It's something that has magnitude and something that has force. So when we have a vector, we're gonna have both of those. If we're missing one of those, if we're missing direction, what do we have? A scalar quantity, okay? So a scalar quantity doesn't have direction. So our forces, our vectors have 4 things, or 4 characteristics. They have a point of application, where they are applied to. They have a direction that they're working in. They have a magnitude, and they also can have one more thing. Does anybody know what that is? They've got a force. They are a force that has a point of application, a direction, and a magnitude. Is there anything else could be used to describe this force? A unit, okay? Magnitude is just described by what? A number. Direction is described based either on the 360 degrees or in radians, okay? But we've got to have a unit. Because if I exert 5 pounds of force, that's different than 5 newtons of force, okay? And we learned the last time we were in class that we have different units within engineering. We have these wonderful kips and slugs and things like that. So we've got to have our units. So let's start off with a vector, okay? This is vector A. Okay? This is vector A. What can you tell me about vector A?
Lies on the x-axis.
Okay, we're gonna assume that it lies on the x-axis.
It's moving in the x direction.
Okay, it's moving possibly in the
Yeah, there you go.
positive x direction. If we're gonna say it's on the x-axis, what do we have to do to describe that vector? We've got to say that this point that it originates from is what?
Origin.
The origin. We'll call that 0, 0, right? Just because I draw a vector, just because I draw a line going horizontal in that direction, does that automatically mean that it's at the origin? No. Now it's at the origin for where that line starts, but it may not be at the origin for our system. Okay, so if we have two vectors, vector A and then we have vector B, okay? And they're both incident on the same point in space. In our case, we're gonna call this on the origin, okay, on the origin. We need to look at what happens when we apply both vector A and vector B, okay? So we look at what we call the sum of the vectors, which is called the resultant. Okay? Now, I know y'all experienced some really fun and exciting things this past week that you were off. But there is this curve that's between my house and town. I don't live in town, you know, so I have to go to town. And this curve is notorious for freezing over whenever there's a little bit of moisture and it's really cold outside. So a truck can come along and be just fixing to go into this curve, and then all of a sudden, instead of turning to follow the curve, it's going straight and sideways at the same time. Okay? Just a great experience to encounter. Okay? So, why does it do that? Why does it do that? Why doesn't it follow the road? Or better yet, the same thing can happen on a straight road. You're driving along and all of a sudden you're sliding sideways. Because the force that's exerted on your vehicle is the resultant force of the forces as a group that are applied to your vehicle.
Yeah, you lose
Okay.
friction, then
You lose friction, or you know, if you're old school, you're driving a 1970s Model 4 pickup that's only got one rear wheel that turns,
oh no.
no positive traction. So as long as you're straight and friction exists, you're going straight. You get a little slickness, what happens? That wheel starts doing this and you start sliding sideways, and you learn how to dance and grip with muscles that you don't normally use to grip with, okay? So we want to sum our vectors. We can do this graphically. This is vector A, and then we can do it like this, vector B. Okay? The resultant vector here starts at our origin, comes up here, and its resultant vector R. Its resultant vector R. Now, let's go back and look at vector A and vector B. Let's say that vector A is 5 pounds of force, and we're gonna go with what we decided earlier. It's at 0 degrees, which means it's along the x-axis, okay? Let's look at vector B. Vector B is 7.6 pounds at 35 degrees from the x-axis. Can we just add those two numbers together and say that we have 12.6 pounds somewhere between 0 and 35 degrees? No,
No.
because vector A
Could have
has,
components though.
you could break it into components because it has an X component and a Y component. And what's really gonna be exciting as we move on to the course, we're not just gonna stop with X and Y components, we're gonna get X components, Y components, and Z components, okay? So we'll start off here. So let's look at this, okay? We have an angle between A and B, which we call theta, which in this case is equal to 35 degrees. Now, going back to our XY coordinates, okay? Will you not agree with me that there's a 35-degree angle in the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant? What's different about those angles? The reference point and the sine and the cosine values, okay? So just keep that in the back of your mind, that changes, okay? Now, in statics, we're gonna represent our angle using this symbol. Okay, since we're measuring this from the x-axis, we're gonna represent it that way. If we had measured it from the negative x-axis, we could represent it like that. But we're not gonna do that because we're smarter than that, right? Because we know it's going in which direction? The positive x direction. Okay, so we've got our vectors. We're looking at our vectors. We have some interesting mathematical equations that we can describe. Vector A plus vector B is going to be equal to what? Vector B plus vector A. Okay? Because we're going to add them together. The components of vector A, the x component of vector A is going to add to the x component of vector B. The y component of vector A is going to add to the y component of vector B. So that we have a resultant component which has both x and y portions. Okay? Can you add more than two vectors at one time?
You could if you split them up by components or.
If you split them up by components. Think about our vehicle. What was causing that vehicle to travel? Think about what was causing that vehicle to travel.
Rotational force of tires pushing up.
Okay, yeah, tires, but remember that rotational force of that tire is just friction. It's just pushing against the ground. You take the friction away, it's just pushing. Okay, that acceleration goes to zero, right? Except you're going downhill. What else is causing that vehicle to move? Come on, let's think about this. This is really good. This is really good. Hopefully you didn't open up a root beer before you got in the vehicle. You know, hopefully, okay? Because if you did, the sloshing of that root beer would do what? As you hit the curb, you know, and hit the little rust spots, it would have a little bit of force, right? What about moving in the seat? Because you know, you didn't have your seatbelt on, so now you're jerking the seatbelt around, plugging it in, because there's a tree up there that looks like it might hurt. You're moving around a little bit, right? What about the dude behind you that was not paying attention? He was on his cell phone,
Oh, no.
and he's sliding right there with you, but he's a little bit faster. And he's got ball tires. And he's gonna bump you, and what's gonna happen? You got all these forces, right? It's kind of like playing pinball. You're gonna bounce here, there, and yonder. Okay? Where are you gonna end up? The sum of all those forces in the direction that sum takes you. Okay? Same thing's gonna happen here. So we know how to do this. We've done this, right? Okay, you've done this. You have done this in physics, okay? You have done it, okay? So, let's look at it. Okay. So, where do you think your limit will be? 1 force, 2 force, or 3 forces, 500 forces?
As many as you feel up to calculate.
As many as you have applied. Okay? If you're building a bridge, how many forces do you have to take into account?
A whole
Every
bunch.
force that's instant on that bridge, even the wind. Even the wind. Okay? So, there are 4 cases of vector addition. Case 1. Vector A and vector B are along the same direction. What happens? vector A and vector B. They're on the same axis. They're on the same plane. How do we add those vectors?
They're both X components, just add them together.
Well, are they necessarily X
They're
components?
not same components.
Okay, we're assuming, which we don't need to do, that this is always the X axis.
They're on the same.
They're on the same plane.
Same plane.
They're on the same plane. So vector A plus vector B is equal to our resultant vector, which is equal to 5 pounds plus 7 pounds, which is 12 pounds at what angle?
0 degrees.
At 0 degrees. Okay, it's 5 pounds plus 7 pounds, that is 12 at zero degrees. Okay? That's our first case. That's our easiest case. Okay? That's our easiest case. Case 2. We have vector A, or force A, being added to force B. Force A is 5 pounds. Force B is 7 pounds. How do we add those vectors?
Would be 5 plus negative 7, right?
Well, we could say that it's 5 plus a negative 7. But why do we want to say that it's a negative 7?
Because it's moving in the opposite direction.
This is moving in an opposite direction, which means what? Or how do we determine that we need a negative sign? If we're looking at the XY coordinate system, this side of the X coordinate system is a positive value. That side of the origin is a negative value. So it forces it to have a negative sign. Okay, so what we're doing here is we're adding vector A plus a negative vector B, because we're still summing our vectors. Okay, so that means we have 5 pounds plus a negative 7 pounds, which gives us what? Our mathematical people here that can do math in their head? A negative 2 pounds at what angle?
Still 0 degrees.
Still at 0 degrees. Or, if we want to be different,
360.
we could say that it's 2 pounds at 180 degrees. 2 pounds at 180 degrees. The exact opposite direction. Okay? So we got our first 2 cases. Works out well. Works out well. Okay? Now, are we going to encounter many of these in the first 2 cases?
Probably so.
Probably not. Probably not. Okay, so we're going to pick case number 3. And I'm not an artist. We'll just go ahead and state that to begin with. We've got vector A, or force A, and force B, but they are at 90 degrees to one another. They are at 90 degrees to one another. Okay? We can't just add them or subtract them. Okay? We can do something that you probably heard in physics called the tip to tail addition. Okay? It might also be called the parallelogram method of addition. Okay? But parallelogram is a hard word to spell. Tip and tail is more on my speed, but it's the same thing. Okay, so we take, remember vector A was 5 pounds, vector B was 7 pounds, so we draw vector A. And then at the head of vector A, the point, we put it vector B. Okay? Now, we draw a resultant, okay, that goes from the head of, or the point of origin of vector A to the point of vector B. This is our resultant vector R. Okay? Now, what do we have to do in this case? We can't just add them. If we've got a 90-degree triangle, Pythagorean's theorem. You know, Pythagorean's theorem is one of the most important things you're gonna see for stuff outside of going to school, okay? It's very important, okay? You can use it for many things around the house, you know, setting your basketball goal up, measuring how tall a tree is in the yard, so if you wanna cut it to see if it's gonna hit the neighbor's fence, okay? Deciding if your walls are square in your house. So if we're at a 90-degree triangle, R squared is going to be the square root of A squared plus B squared for the magnitude. In this case, the amount of force. Okay? So R squared would be square root of 5 squared plus 7 squared. That's 25 plus 49, right? That's 74. So square root of 74 is less than 9 and more than 8. How about that? Right? Do that much in my head. Okay? 8 and 8, 64, right? 9 and 9 is 81. So somebody pull out an artificial intelligence device and tell me what our magnitude is there.
Okay. Do you want exact or decimal?
Oh, let's not get into the math part. Give me a few decimal points.
8.6023.
And all those numbers are important, right? No. I bet if we had a different calculator and we turned it sideways, we'd get more digits. Okay?
Yeah, I got more digits, but I can't cut it off after 4.
How many digits do you want to carry? Maybe 2 or 3 after the decimal point?
Yeah.
So let's say 8.602 pounds. Okay, now, we've got to come up with a direction. How can we come up with a direction? We're looking for this angle right here, right? So theta is what we're looking for. Can't we use the tangent of theta, which is equal to what? Opposite over the adjacent. We've got opposite and we've got adjacent values. And it's very important to note this at this point. We have opposite and adjacent values that are given to us, not calculated by us. Because if they're calculated by us and they're wrong, what's going to happen? You're going to get the wrong angle. So make sure you use as many values that are given to you as possible. So tangent of theta is opposite. What's the opposite value?
7.
B, right?
Yeah.
Over A, which in this case is 7 over 5. So what's theta equal to? Tangent of theta is equal to 7 divided by 5. So theta is equal to the inverse tangent of 7 over 5, right?
Set that to
And I want it in degrees. I do not want it in radians. So make sure you do it in degrees. So how many degrees is it?
54.46.
54.46 degrees. So we now know by our tip to tail addition, our parallelogram addition, that we have 8.602 pounds at 54.46 degrees. Okay? So that's case 3. So case 1, case 2, and case 3 are our simplest cases. They take into account some simple math, okay? You know, Pythagorean theorem is not simple, but it is simpler math. We all know that. When did you first hear about Pythagorean's theorem? Do you remember? About 6th grade. Maybe you went to a slower school, 7th grade, okay? So you've seen it, okay? You've seen it multiple times, okay? So we've got case 4. What will happen if we add 2 vectors and we're still at 5 pounds and 7 pounds? We do 2 vectors, okay? But they're not at 90 degrees. They're not at 90 degrees.
Could still do tip to tail, but be a little more difficult.
We could do tip to tail. We get resultant vector R, right? But now we can't use Pythagorean's theorem. Why not?
It's not a right triangle.
Not a right triangle. So how can we add? We've got to find the x components and the y components, okay? So we would have the x component of A, which would be A times the cosine of the angle. The y component would be A times the sine of the angle. Bx would be B cosine of our angle. By would be B sine of our angle. So that Rx is equal to Ax plus Bx. Ry is Ay plus By. Okay? Now, how can we find the magnitude of R? R squared is equal to square root of Rx squared plus, I guess R would be that, R squared, sorry. Ry squared.
Okay, we have to figure out what angle. Well, if we're assuming A is saying.
Yeah, let's say this one's 40 degrees. So this would be 40 degrees.
Okay, that makes it simpler. That's
Okay? So that would make it a little bit simpler. So we've got 4 cases. We've got 4 cases. And we're gonna use all 4 cases. Okay, now, before we get much more to this, I wanna go through a little trig review, just to remind you of some things, okay? That you are gonna need to know, okay? Now, I have the same information in videos and in worksheet or help sheets, tip sheets, in that first course information module, okay? But there's a lot of links in there that you gotta click on, okay? So let's go through with them, okay? First thing for our trig review. If I have a triangle, number 1, the sum of all interior angles is equal to what?
180.
Okay? If I have two angles there, okay? If I have 2 angles, I can state number 2, complementary angles sum to be 90 degrees. And you're thinking, these are really simple thoughts. The first two are. But I don't know if you've started looking at your problems in your book. Okay? When they give you an angle, where do they measure that angle from? Not in the x-axis. Okay? They may measure it from the y-axis. Okay, well, if you measure that angle from the y-axis, you need to know what the angle is from the x-axis if you're going to use sine and cosine with respect to the x and the y-axis. Otherwise, you're going to have to flip around and use sine where you needed to use cosine, or cosine where you needed to use sine. So you need to know those two relationships there. Okay? If I have a vector like this, I've got this angle and this angle. Supplementary angles add to what? 180 degrees. Supplementary angles add to 180 degrees. Am I going too fast for you? You got everything? Okay. Now, use your imagination on this next drawing, okay? I've got two parallel lines, okay? Bisected. Oh, that just looked like from something from Hawaii 5 right? By a line like that, okay? Now, what do I have here? I have a parallel line, set of parallel lines bisected by another line. Now, if that was a perfect bisection so that I had 90-degree angles, you could agree with me that all the angles would be equal, right? But it's not a 90-degree angle, okay? It's not a perfect square at any point. How can I describe the angles there? I can say that this angle is equal to that angle, right? Which makes this angle equal to that angle. Oh, why not put Q? Well, Q will work. Okay? And guess what? Right? Guess what else is true? Theta and theta. Okay? Adjacent angles are equal. If I've got parallel lines or parallel lines, that are bisected, angles are equal. Angles are equal. Okay? We're going to call them adjacent. Well, what does adjacent mean? What does adjacent do? Next to. Now, when you're thinking adjacent, you're thinking of somebody sitting side by side. But when we're looking at adjacent, we're looking at across the parallel line. Across the parallel line. They touch, but they touch across the parallel line. Okay? Okay. Everybody knows this relationship. Miss Sims tells me that y'all all know this. Okay, you know this. The word SOHCAHTOA.
Sine is opposite of the
Okay, so SOHCAHTOA. Sine equal, oops, not yet. It just doesn't want to erase today. Sine is equal to opposite over hypotenuse
cosine is adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Okay? Now, I'm gonna assume that you know certain angles, what their sine, cosine, and tangent is.
I have.
Okay, like a 30-degree angle, a 45-degree angle, a 60-degree angle, a 90-degree angle, a 0-degree angle. Okay, now, does that mean I'm not gonna let you use your calculator? No, but you know what those are, okay? You know what those are, okay? One more note here, which, well, two more notes, sorry. The law of cosines. Okay, the law of cosines. If I have okay, come up with a representation like that. Okay? The law of cosine says that r squared is equal to, I want to make sure I get this right. Y'all have seen the law of cosines, right? Okay, y'all have used it before, right? All the time, right? A squared plus b squared minus 2ab cosine of b. Okay? Just plug in. Okay? Now remember, your statistics teacher is like their chemistry teacher named Stringfellow. He's kind of evil. Okay? Make sure that you use numbers that are given to cut down on the error. To cut down on the error. Okay? Because sometimes you might make a mistake. Okay? Then we have one more. This is the law of cosines. Okay, we've got one more, and it's called the law of sines. Okay? There's no law of tangents. Man, it would solve so many problems when we get to trusses if there was a law of tangents, but there's not a law of tangents. Okay, so if we have the same crooked line there, A, B, R. The law of sine states that with the sine of angle A over the magnitude of A is equal to the sine of angle B over the magnitude of B, which is equal to the sine of R over the magnitude of R. Okay, with sines, where is A? Where's the angle A? Where's angle B? And where's angle C? Opposite sides. So, A, this would be angle A up here. B, this would be angle B here. Okay? So we've got a ratio there. The law of sine. So those 7 things can allow you to calculate things about your vectors that you're going to use. Okay? So we should be able to add vectors together and find the direction and find the magnitude. Agree? Okay, so we're through with our introduction on vectors. If you'll push the button there, that'd be great. Okay.